Welcome back to Database Internals Crashcasts. I'm Sheila, and I'm here with Victor to dive into another exciting topic in database design. Before we begin, I'd like to remind our listeners to rate our podcast on your preferred platform. Your feedback helps us improve and reach more database enthusiasts like you.
That's right, Sheila. Your support means the world to us. Now, let's get into today's topic, converting ER models to relational models. This is a crucial step in database design, bridging the gap between conceptual modeling and actual database implementation.
Absolutely, Victor. But before we dive in, I have a quiz question for our listeners. Here it is. In the process of converting an ER model to a relational model, what do we typically do with a many-to-many relationship between two entities?
Oh, that's an intriguing question, Sheila. It touches on one of the trickier aspects of this conversion process. I'm curious to see how our listeners approach this. It's not as straightforward as some might think, and there are a few considerations to keep in mind. But let's not give away too much. We'll reveal the answer at the end of the episode.
Great point, Victor. Now, to set the stage for our discussion, could you briefly explain what ER models and relational models are?
Certainly. An entity relationship, ER model, is a conceptual representation of data that describes the relationships between entities in a domain. It's often visualized using ER diagrams. On the other hand, a relational model is a way of structuring data using tables, columns, and keys. It's the foundation for most modern database systems.
Thanks for that clarification. So, why do we need to convert ER models to relational models?
Great question. While ER models are excellent for conceptualizing data and relationships, they're not directly implementable in most database systems. Relational models, however, can be directly implemented in relational database management systems, RDBMS. The conversion process bridges this gap, allowing us to go from a high-level design to a practical database structure.
I see. So, how do we start this conversion process?
We typically start with the simplest elements. Entities. Each entity in the ER model generally becomes a table in the relational model. The attributes of the entity become columns in the table. For example, if we have a student entity with attributes like student ID, name, and age, we'd create a student table with corresponding columns.
That makes sense. But what about the entity's primary key?
Excellent point. The primary key of the entity becomes the primary key of the table. In our student example, student ID would likely be the primary key. It's crucial for uniquely identifying each record in the table.
Got it. Now, things seem straightforward with simple entities, but what about relationships? How do we handle those?
Relationships are where things get more interesting. The way we convert relationships depends on their cardinality, whether they're one-to-one, one-to-many, or many-to-many. For one-to-many relationships, we typically add a foreign key in the many-side table that references the primary key of the one-side table.
Could you give an example of that?
Sure. Let's say we have a department entity and a student entity, with a one-to-many relationship where one department can have many students. In the relational model, we'd add a department ID column to the student table as a foreign key referencing the department table.
I see. But what about many-to-many relationships? They seem more complex.
You're right, they are trickier. For many-to-many relationships, we typically create a new table, often called a junction or associative table. This table contains foreign keys to both of the related tables. For instance, if we have a many-to-many relationship between student and course, we'd create a student course table with student ID and course ID as foreign keys.
That's fascinating. It seems like there's a lot to consider. Are there any common pitfalls people should watch out for when doing this conversion?
Absolutely. One common mistake is not properly handling composite attributes. These are attributes that can be divided into smaller subparts. For example, an address attribute might include street, city, and zip code. In the relational model, it's often better to split these into separate columns for more efficient querying and data manipulation.
That's a great point. How does this conversion process compare to other data modeling techniques?
Well, compared to object-oriented modeling, for instance, the ER to relational conversion is generally more straightforward. Object-oriented models can have complex inheritance hierarchies that don't map directly to relational structures. However, the ER to relational conversion does share some similarities with dimensional modeling used in data warehousing, especially in how relationships are handled.
Interesting comparison. Now, before we wrap up, could you share a best practice or tip for our listeners when they're converting ER models to relational models?
Certainly. One crucial tip is to always keep normalization in mind during the conversion process. While faithfully converting the ER model is important, you should also consider normalizing your relational model to minimize data redundancy and improve data integrity. This might mean further breaking down tables or adjusting relationships.
That's excellent advice, Victor. Now, I think it's time to reveal the answer to our quiz question. The question was, in the process of converting an ER model to a relational model, what do we typically do with a many-to-many relationship between two entities?
Ah yes, the big reveal. The answer is that we typically create a new table, often called a junction or associative table, to represent the many-to-many relationship. This table contains foreign keys to both of the related entities' tables. This allows us to efficiently represent the relationship in a relational database structure.
Thank you, Victor. To summarize today's episode, we've learned that converting ER models to relational models involves mapping entities to tables, handling relationships based on their cardinality, and carefully considering attributes. We've seen how one-to-many relationships often involve foreign keys, while many-to-many relationships typically require a junction table. We've also touched on the importance of normalization and avoiding common pitfalls like mishandling composite attributes.
Excellent summary, Sheila. This conversion process is a crucial skill for database designers and developers. It bridges the gap between conceptual modeling and practical database implementation.
Absolutely, Victor. And to our listeners, we hope you found this episode informative and engaging. If you did, please consider supporting us by visiting crashcasts.com, joining our Discord community, or supporting us on Patreon. Your support helps us continue creating content like this. Until next time, happy database designing.